first set of panelists, which hopefully had time to eat. Satish Gandhi from AWS, Anil Nanduri from Intel, and then Wig Slagter from Ansys. We're going to kick off and talk about domain-specific architectures, accelerated architectures. And then before we get started, just talk a little bit about intro for each of our panelists. And I'll read a short intro on the folks here. What I'd love to do as we kick off is for you to share a little bit more about yourself, and also what's your favorite quote or favorite dad joke? Up to you guys, all right? Or mom joke.
Yeah.
So Satish Gandhi is a principal strategic technology partnerships at AWS, manages tech partnerships with those using HPC, and many years. That's going to be a theme here. A lot of us here have many decades of experience in CAE, with work at Boeing, Dassault, Ansys. So welcome.
Thank
Satish.
you.
Yeah, you can clap.
You.
You can clap. Yeah. To his left is Anil Nanduri. Anil is a VP of Accelerated Computing for HPC, AI, and Visual Cloud at Intel. Joined Intel since 1997.
Yeah.
So you've seen some stuff, right?
Yeah.
Education and electrical engineering. And I look forward to hearing your perspectives on Moore's Law and all that good stuff.
Yes.
And then to my right, we have Wim Slagter, a Director of Partner Programs at Ansys. Wim's responsible for the design and execution of the partner programs at Ansys. Over about 30 years experience in engineering computing, doing a PhD in aerospace engineering. And fantastic, yeah. Please welcome Wim. All right. So Satish, why don't you get started? A little bit more about yourself and what's your favorite dad joke or quote?
Yeah. First of all, thank you, Rescale, for this opportunity, and thank you, everyone. Thanks, Ed, for having all of us here. As Ed mentioned, I manage our high-performance computing and quantum computing partnerships at Amazon Web Services. I'm based in Seattle. I've been with the company for a little over 4 years now. And before that, as Ed introduced, I spent almost 20 years in CAE industry. But the kind of partnerships that I manage are mostly focused on, of course, CAE, but also high throughput computing, like EDA workloads, as well as computational chemistry, molecular modeling, and all. And many of you are familiar with reservoir and seismic modeling. So that is what my role is. And before I joined AWS, I used to be at Ansys. I see some of the folks in this room are from Ansys. So I collaborated with Rescale I have been collaborating with Rescale for almost now 8 years. And it's been an exciting partnership. Now coming back to your question, what is my most, one of the not jokes I would go with, but the quote. So our founder, Jeff Bezos, the quote, one of his quotes that inspires me to do what I do every day is around customer obsession. So if you're familiar with Amazon's leadership principles, one of the principles that we have, out of 16 principles that we have, is customer obsession. So to quote him, the thing he said, I think several years ago, the single most important thing is to focus obsessively on the customer. Customer needs constantly change, and we have to constantly adapt to those changing needs. And that is exactly what has driven Amazon to become what it has become. It has been driving success at AWS, and also it has really inspired me to do what I do on a daily basis. So for example, identifying the right partnerships. Also, as we are building and growing our partnerships, we are looking at partnership from a perspective of how it is going to help our end customers solve their challenging problems that they have using our high performance computing infrastructure. And that is where culturally having a partnership with Rescale, it's a perfect fit, because I have seen, having working with Rescale, I've noticed their culture is very similar to ours, very much focused on the customer. But that does not mean that there is no company out there who will say we are not customer obsessed or we are not customer focused. But saying is one thing. What I'm noticing with many of the companies that I work with or that we try to work with is they have the statement about customer obsession or customer focus, but when it comes to their processes or their mindset, it is not the same way as our culture is. So I think having this customer obsession has been a big factor in helping me do what I do on a daily basis. With that, I'll turn it over to you, Anil.
Yeah. All right. Thank you, Rescale, for having us. Wonderful to have everybody here. Thanks for taking the time. Can you hear me? Yeah. Okay. All right. So I'm Anil Nanduri, Vice President of AI and HPC category. My day job is responsible for worldwide consumption of all our accelerator products, from our Gaudi accelerators to our GPU accelerators, as well as our processors for the HPC segment. We have our Xeon high bandwidth memory and Xeon for HPC. So as a code, really, another founder, but then Robert Noyce, said something very interesting. And he said, don't be encumbered by history. Go do something wonderful. And he continues that with, optimism is an essential ingredient for innovation. This has been something, as Intel, you'll say, I've worked here 25 years, very surprised. In fact, you'll find a lot of Intel employees who've been there a long time. The culture is pretty interesting in terms of how we end up staying there. Sabbatical is a perk. Every 7 years, you get 8 weeks off. So that does help to keep the count going. But I've done many roles at Intel, from Centrino, if you've heard of the laptops that kind of brought wireless to the mainstream, to RealSense Technologies, which was the mainstream of autonomous devices and mixed realities for depth sensing, and that led me to do drones and drone swarms and light shows, and then since then moved into high performance computing and supercomputers and GPU applications. And so it's every step along the way is kind of an entrepreneurial spirit. It was big challenges because these were all incubated at it. And as you know, incubating a new technology inside a big company is never easy. And it taught me a lot. We've had our ups and downs, but what we always look at is the North Star and make sure we have forward progress.
Thanks, Neil. Wim.
Yeah. I'm from the Netherlands, as you can hear from my Dutch accent. I'm very pleased to be here. Actually, I was signing up Rescale as one of our partners, cloud partners, in the early days, and I'm very excited about that. I mean, as you know, Ansys is the prime CAE provider. Yeah, we make sure that the customers using laptops, mobiles, driving cars, are innovating faster and faster at lower cost than ever before and bring their products faster to market. But we can't develop those products without any good partners. Yeah, of course, we partner with Intel, we partner with ARM, we partner with AWS, and we have to partner, of course, with Rescale, because Rescale clearly are so dedicated. They have application engineers specific to Ansys and help our customers to be more successful, to bring their products faster to market, more innovative products at lower cost. So I'm very pleased to be here and being part of this panel as well, and to give our perspective on, I guess, some questions you will have for us.
Yeah.
As a quote, I was thinking about that too, and it must be something related to cloud, obviously, because that's. So I was thinking in the cloud, engineering simulation reaches new heights. Yeah, and where the sky is not a limit, but just the beginning of what's possible. And that's, I was thinking of as a nice quote.
That's your quote.
That's my quote.
Wow. All right. That's a first here, guys.
So, thank you. But it's true. I mean, the cloud will enable to reach new levels of innovation, higher fidelity. I mean, there are no barriers then anymore for our customers.
Yeah, thank you. So I'll also contribute with my own quasi-dad joke. Recently, I realized that I was sick of listening to Moana like 500 times in my car. So I downloaded this book of 3,000 fun facts. And then one of the facts, all spoken in British accents for some reason. California is the nearest state to Hawaii, but Hawaii is the farthest state from California. And I was sitting there and I was like, wait, how's my 7-year-old son's like, yeah, that makes sense. And I was like, no, it's not computing for me and my computer science background struggling with this stuff. Anyways, so that's my quote. Yeah, and then thanks for the kind words on Rescale. Sometimes it's a little hard to explain what Rescale does. And for my sister, who's a dentist in Switzerland, I say our goal is to make it sexier to be an engineer, right? Because we're automating the full stack. So you can solve your problems and move on and look good. So let's get to some of the questions. So one of the things that are clearly happening now is the advancements of all these domain-specific architectures. The challenge, of course, is when you have all these new architectures that are coming in so quickly, and organizations, certainly the ones that are pre-cloud, are still thinking about buying infrastructure for 3 to 5 year cycles. And certainly in the cloud, you can adopt it more quickly. How are you seeing organizations struggle or not struggle to be able to use the latest architectures? Feel free to.
You want to go first?
Yeah, go ahead.
Yeah, no, that's a great observation. And what we see from our side, of course, cloud actually offers vast area of cloud architectures. But with companies, with organizations of different sizes, it can be very daunting, right? Even like not just for startups or not only for companies that have never done cloud deployment, but also for large enterprises. It can be a daunting task. And so, I think approaching cloud adoption, it is very crucial that the companies consider what their business priorities are, what the constraints are, what the objectives are. Yeah. Absolutely, they have to look into the trade-offs before even deciding what kind of architecture or whether even the cloud is the right fit. Yeah. And also, which particular cloud provider will be the right fit for them, right? Yep. And so I would say there are several considerations and trade-offs that the companies should be looking into. One is definitely what the business objectives, what the business goals are. So why exactly is an organization considering cloud adoption? Is it considering adopting the cloud across the entire organization or within a particular department? Could be engineering, could be finance, could be HR. Also, what exactly is the skill set that the organization has in terms of are they very much traditional IT? Do they have traditional IT expertise, or they have up-leveled or upskilled their IT teams to even do the cloud deployment? Extremely critical, right? Also, cost optimization. Various cloud providers offer and architectures, they can lead to very different costs, right? So it's very important for organizations to do a good assessment of what the cost will be, how to optimize the cost without compromising the performance and scaling of their workloads. Which brings me to the next point is about scalability and performance. All of us in the room have used a variety of different applications. Could be Ansys, could be computational chemistry workloads, could be EDA workloads. So it's very important to assess what the scalability of the cloud is going to be, what kind of architectures will lead to optimal scalability, optimal performance. Yeah. And you have to see what exactly will be the price performance before even, and in some cases, price performance might be more critical than the performance. In some cases, organization may want to go faster. In that case, performance plays a more critical role than looking at the price performance. So that defines your architecture. Yeah. Then the security, right?
Yeah, there's a lot of factors. I guess the question becomes, just because I know I want it, because it's good, are people going to be able to just use it right away? So for example, I imagine at Intel, you would love to ship a chip and have somebody use it the next day. Does that actually happen?
Okay, so actually with our x86 architectures, we've been fortunate to have a strong software compatibility that enabled speed up and performance. But to answer the first question, we have to look at what's driving this, right? And if you go back to the essence of what's driving this is demand for compute. Okay, if you look at the compute demand historically, you've had compute demand and Moore's law, go every 2 years, you would double the performance and the capability, and it kind of met the needs of the compute demands. Yeah. But as more and more AI and Gen AI have come in fact, you're looking at compute demand doubling every 6 months, whereas the traditional Moore's law was actually doubling performance every 18 months or 2 years. Yeah. Okay. Now, we can put the debates on whether Moore's law is slowing down or not, but what is really happening is that just relying on process technology to double your performance is not going to meet the fundamental requirement of that doubling of the compute demand. Yeah. So then you get into the next layer of, okay, this is a golden age of architecture. So you have different layers of compute capabilities. You have interconnect. You have memory bandwidth then becoming a bottleneck. And then you have I/O becoming a bottleneck.
Yeah.
And then you have system architecture, innovation.
Yeah.
And then last part of it is software.
Yeah.
Now, people are solving the different layers. But what you said is important, is how am I bringing the software developer along with me so that the last thing anybody wants to do is rewrite code. And so if you asked about what is the secret sauce in the person or the innovation that comes in that can actually bring the existing software stack and have an abstraction layer that can actually get the performance optimizations under the hood without having to recompile new software or recode, in fact. Compilation is a little easier step, but then rewriting the code and not having to do that, it becomes a key aspect. Now, you can innovate on new applications. So when you have AI and when new models are being created, new software has been created, they can then be optimized for the new architectures. But the legacy solutions where a lot of our HPC applications are built on, based upon years of data has been collected and specialized and optimized to, need to come along with it.
Adoption architecture is something that takes order of quarters, months, or years, before they run those on their Ansys deployments. Because I'm sure they're doing that to try to get more out of their Ansys.
Oh, for sure, for sure. That is key. I mean, performance is key, but it's often a balance between performance and cost, obviously. And it depends on the organization as well. So people clearly want to have a choice too, in terms of architectures, different SKUs. The different Ansys applications has also different requirements, on the architectures. And so clearly customers want to have a choice.
How do people know what to use?
That is indeed a challenge. That is a challenge. Because, I mean, there is nowadays so much choice out there. So people need to be, of course, very well aware what's out there. Of course, being part of this conference is one step. Being part of international supercomputing, going to HPC events is crucial. Having partnerships in the first place also, collaborate with research organizations, with technology partners, with cloud partners like Rescale, of course. It's very important to be on the top of the edge, on the edge, say what's available. Continuous training, I would say, is also key.
Continuous training
of the people as well. Training as well as learning. Learning through the events and training, following trainings, for example, offered by AWS, by Rescale, by Intel has an online training database is enormous. Of course, Ansys provide also innovation courses, as well as we conduct webcast trainings, IT webcast, cloud developer trainings, etc. as well. So I think on that level you can.
And what are the biggest kind of mistakes you guys have seen? Let's say I'm trying to do weather modeling, but I'm buying the entirely wrong architecture that's committed myself. What are some examples you guys have seen where people have maybe tripped over the fact is there's too many choice now because they weren't navigating it properly?
Go ahead.
There's one example I can give is, sometimes you look at, what is your limiter in the performance boost? We tend to look at compute performance, then you realize that, no, it's been the memory bandwidth is actually the bottleneck, or it's not enough I/O bandwidth. And so this interdependency of the various building blocks of this, stack starts to become more and more important and relevant. Right? Do I throw more cores at it? Do I throw more memory at it? Do I throw more bandwidth at it? And sometimes you can get that ratios wrong. And then you don't see the outcome of that performance as you would expect.
Got it.
And
that's at the hardware level, right?
And I think if I may add, I think what I'm noticing or what we are noticing at AWS is companies, organizations, hundreds and thousands of customers out there, they are still viewing cloud computing in the same way as on-premises infrastructure. Cloud computing is totally it's a different paradigm, right? And so you can build clusters. All of us are familiar with HPC, right? So you can build clusters and tear down that cluster within a minute. Whereas on-premises, you will have a fixed capacity for multiple years. There is a different way of operating, like when you have on-premises infrastructure, which we all are familiar with. But when it comes to cloud computing, it's a totally different paradigm. 50,000 cores, spin up, tear down within an hour, run your fluent analysis or mechanical analysis, bring it down. So I think one of the pitfalls that we notice is like educating, and I think going back to Wim's point is educating customers, end users about like what exactly cloud computing can offer and how is it different than your traditional way of computing, and also educating the IT teams, like how to use this technology we have. Some of you may be familiar with like, and that all our EC2 compute. 700 plus instance types we offer, CPUs, GPUs, right? And it's practically impossible for anyone to know which particular compute instance we should use for running a particular like structural model or crashworthiness model. It's very difficult, right? And that's why understanding about like the nuances of like what cloud computing can offer, which particular instance type might be a right fit for explicit or like implicit kind of analysis. There is an education component that has to be accelerated or amplified, which I'm noticing that companies are not investing enough on that educational component. Even though like, we are providing programs, Ansys is providing Intel, and Rescale is providing, but I think there is a little bit of a gap where companies are not leveraging all that. And until that happens, it's going to be very difficult for organizations to optimally use cloud computing or see the value of cloud computing that it can offer. And that's why it's extremely important for us and many other companies to have this partner ecosystem, like for example, Rescale and many others, right? Like we have developed a strong partnership with Rescale, Intel, and Ansys, and others also that understand the intricacies of cloud computing, the intricacies of compute, networking, storage that we offer. And they are the ones who engage with organizations to push them to build these architectures that deliver the best price performance for your kind of workloads.
I think in addition to that, I think one of the pitfalls is the lack of executive sponsorship. That's what I see. There must be alignment with the
sponsorship
business
for cloud or
for cloud in particular. There needs to be executive support or executive sponsorship for going to the cloud. There needs to be an alignment with the KPIs of business-driven objectives. That is very key as well.
And by the way, that's why we like what Rescale does, which is kind of simplifies the problem.
I'm not tipping these guys, by the way.
No, but that's your value prop, right? Is to kind of help the make it easier for them to understand which compute instance best works for the outcome. And then being able to provide that as a service and helping them to get to the right outcome is probably
in our office.
He didn't tip me, but
in our offices in San Francisco, we have a giant mural that shows over time the distribution of compute being used across the different architectures. And it goes back since the company was founded, and it was like 3 or 4, well, we call them core types, but instance types. And you fast forward today, and now it's a very complicated chart with many different colors, including one part that's other. I want to jump over to one last question, right? So computing obviously is so critical for engineering and scientific progress. And you guys all probably heard that the data center carbon footprint is equivalent to all commercial aviation traffic, right? And then the Australian government did a study few years ago that said that the carbon footprint of an astronomer in Australia is more from computing than everything else combined for that astronomer, including travels to conferences like this, including office, including everything. So if we're going to be doing more aggressive scientific computing, it's really going to increase the carbon footprint. What are you guys doing in your organizations to kind of try to manage this and move us towards sustainability?
Yeah, if you allow me, of course, there are different aspects to sustainability, of course. There is sustainability of making more sustainable products, of course, using our software. That's clear. That's a clear an objective that is top of mind of our customers. Not least because their end users, their consumers, ask them to come up with more sustainable products. So, for example, a car. If you think about a car OEMs, engineers, and so on, want to make sure that their car consumes less fuel. How can you do that? Reducing drag, You have to do all kind of designs.
Right.
If you want to do that with physical prototypes, that is, of course, extremely expensive. Yeah.
Yep.
So in that way, you can use, of course, Answer simulation, but other CAA software as well, to make sure that your product is more sustainable, consume less fuel. But on the other side is, of course, being more sustainable computing. Yeah. The sustainable computing by using more power-efficient architectures, microarchitectures that are energy efficient.
That's right.
And that's clearly top of mind too. Yeah? If you talk about these large data centers, they consume quite some energy.
Sure.
But using the scale of the clouds, you should be a lot better off. By basically more sustainable computing.
Yeah, and
That's right.
Probably many of you must have heard about Amazon founded this climate pledge in 2019, which has now been signed by 420 other organizations in different sectors across 38 countries. And the objective of that is, probably you're familiar with Paris Agreement, to go for net zero carbon footprint. So this climate pledge is actually targeting to go with, to have like net zero carbon footprint by 2040. 10 years ahead of Paris Agreement schedule. Now coming to AWS or cloud computing, I don't know how many of this is public information, but our data centers, what Wim was talking about data centers. So our data centers in North America, Europe, EMEA, and one more region of which I'm forgetting, are fully powered by renewable energy. And Amazon is the largest corporate consumer of or purchaser of renewable energy. So we are doing what, we are going towards a net zero carbon footprint. Also, we are developing our own chips. We acquired a company by the name of Annapurna Labs several years ago, and we develop our own chips. And our goal is essentially, of course, price performance, but at the same time, look at the energy efficiency, the power efficiency, and carbon footprint of those chips. So there is a Graviton chip, which is our own chip, just like Intel has their, AMD has their, NVIDIA has GPUs. We have our own Graviton processors. And those instances are available. Some of you might have used C6Gs or HPC 7Gs that we have launched based on the recent Graviton processors that we have. And the carbon footprint of that compared to, or energy efficiency of those processors are 54% better than comparable instances. So we are investing, we are innovating to make sure that we are driving towards more sustainability, less carbon footprint, not just for ourselves, but for our end customers. And we also have a tool, probably some of you might be familiar with, like carbon footprint tool. So when you run your workloads on AWS, you can use that footprint, the carbon footprint tool to see how much is your carbon footprint when you run workloads on AWS. And you can use it in your sustainability reports. So we are making our best efforts, and I'm sure other organizations here in the room are contributing towards that as well.
Yeah, Anil, what is Intel doing?
Yeah, so we build our own silicon as well, right? Yeah. So our whole manufacturing process, has taken some very aggressive sustainability goals as well. And we publish them on an annual sustainability report. And we have publicly taken goals for 2030 and 2040 on what sustainability achievements we'll have. And as regards to, since the compute chips, of course, for the performance, we are seeing the power density is becoming a more and more critical, element of decision criteria. Power efficiency is a key vector. And additionally, we do a lot of enabling technologies. We invest a lot in thermal and cooling and innovations around the systems on how we can reduce and be more efficient in being able to deploy that power through existing capacities and trying to minimize that increase. So, and then with the added capabilities of renewable energy, how do we as an ecosystem, become net neutral is, I think, what this ecosystem aspires to do. And I think that this is a very important element. And in fact, most of our RFIs and purchase criteria have sustainability as becoming a more and more of a leading metric in end customers' decision criteria. So this is another reason why we as an ecosystem are also, not only it's a need, but out of want, it's also a need to actually go invest in this.
Awesome. Thank you, folks. We could go on and on, but I know we're running out of time. Please say thanks to our panelists. Thank you so much.
Thank you. Thank you.
Yes, thank you.
Thank you, everyone.